So this lesson today, guys, is about the volume of spheres. So this is AKS 8A. And notice that we've got the word spheres right here. So we're looking for the volume of spheres. We're going to solve problems using them. So today we will solve for the volume of spheres and understand how dimensions affect the volume. So first of all, we have here is the sphere, set of all points that are fixed, a fixed distance from the center of the sphere. And then the radius of the sphere connects the center of the sphere to any point on the sphere. A hemisphere is half a sphere, and you guys heard the term hemisphere when you guys were doing geography, okay? So the way we do this is we're going to do 4 times our r cubed and divide that by 3. And remember, we're doing our pi at the end just like we've been doing, because sometimes we want pi in the answer, and sometimes we're going to multiply by pi. So our first problem right here is going to we're going to take our radius. It says find the volume of each sphere, give your answer in both terms of pi, and round it to the nearest tenth. So this is our radius right here. So we're going to do 4 times our radius, 8.25, cubed, and divide that by 3. So do the top, 4 times 8.25 cubed, and then divide that by 3. And what you should have gotten here was 748.7 pi. And then that's your exact answer, and then your approximate answer is going to be when you multiply by pi. Now look, you rounded that first answer. You're not going to round it and multiply it by pi. You're just going to take what's in your calculator and multiply it by pi. And when we do, we get 2352.1, and both of these are centimeters cubed. So this next one says find the volume of the sphere with a diameter of 2.2. Well, we don't want diameter, we want radius. So we're going to take this value and we're going to divide it by 2. So that means our radius is going to be equal to 1.1. So once again, we're going to do 4 times our 1.1 cubed, divide all that by 3, and add our pi at the end. So once again, do that in your calculator. And when you do, you get 1.8 pi. And then when you multiply that number that you rounded in your calculator times pi, you get 5.6. Okay, and again, this is going to be feet cubed. Okay. Now go ahead and do this. You try. Come back to me when you're done. Once again, here, notice this that's our diameter, but so we need to divide that by 2 to get our radius, which is equal to 12. So we're going to do 4 times 12 to the third. And remember, this is third because we got length, width, and height, right? That's really what we're doing here. And all of those are our radius. So then again, divide by 3 here and do our pi at the end. So when I did that, I got 2304 pi. When I multiply that times pi, I got 7,238.2, and again, this is inches cubed. Now, this next problem says find the radius of a sphere with a volume of 972 pi. So our volume formula is, and this time I'm going to do the 4/3 as an actual fraction because we're going to get rid of it in a minute. So that's pi r cubed. This is exactly what's on your formula sheet, okay? So what we're going to do is we're going to put this volume over there on the left. So we're going to do 972 pi equals, and I'm going to leave a little space there, and I'm going to do my 4/3 pi r cubed, okay? So we're going to go ahead and mark out the pi's because they're on both sides of the equal sign. Now, how do you get rid of a fraction? You multiply by its reciprocal, right? So that's going to be 3/4. Flip it and then multiply it, because now that's 12 over 12, which is 1, right? So we're going to take 3/4 of the 972. Do that in your calculator and you get 729. Now this is equal to r cubed. Now you could take the cube root of that number, or you can see that when you multiply 3 times 1/3, what's the reciprocal of 3? It's 1/3, right? So you can take this with your caret symbol in your calculator, take this to the 1 divided by 3 power, right? So when you do that, r is equal to 9. All right, now let's look at this we try down here. Now this time again, we're given our volume, right? So that's going to be 1,150.35. And that's going to equal, again, our 4/3 pi r cubed. So here, I'm going to go ahead and multiply both sides by 3/4. So when I take 3/4 of 1,150, I got 862.76, blah, 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 okay? And that's equal to pi r to the third. So now what we're going to do is we're going to divide both sides by our pi. And again, leave that number what it is in your calculator because we don't round till the end, okay? So there, then, when I divided that by pi, I got 274.625, again, blah, 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 okay? And that's equal to r to the third. So once again, we're going to take that to the 1/3 power, and we're going to take this, whatever that number is in the calculator, to the 1 divided by 3 power. Make sure you put it in parentheses, otherwise it won't give you the answer correctly. And so when we did this, I got that r was equal to 6.5, and this is centimeters, right? Okay, so the next one, go ahead and do this one. Come back to me when you're done. So here we go again. 36,000 pi is equal to 4/3 pi r cubed. Our pi's cancel each other out. We're going to do 3/4 times here. 3/4 of 36,000 is 27,000. That's equal to r to the third. So we're then going to take that to the 1/3 power, and we're going to take this to the 1/3 power, and that means r is going to be equal to 30, which some of you already knew that, right? And that's going to be 30 centimeters. Okay, so the next one says find the volume of the hemisphere. Okay, now think, hemisphere is half a sphere, right? So what's half of 4? 2, you got it. So when we do this, we're going to do 2 times our 15 cubed divided by 3 pi. So go ahead and do that in your calculator. When I did that, I got 2250 pi. And then when I multiply that by pi, I got 7,068.6 meters cubed. Okay? So pause the video, do the next 2. Come back to me when you're done. All right, here again, this is going to be 2 times our 6.1 because it's a hemisphere cubed divided by 3 with our pi. When I did that one, I got 151.3 pi. When I multiplied that number that's in my calculator, I got 475.4, and again, this is feet cubed. Then it says find the volume of the hemisphere with the diameter. Whoop, we got to divide that by 2, right? So our radius is equal to 6 here. So when we do this one, we're going to do 2 times 6 cubed divided by 3 pi, right? So that's going to give me 144 pi. And when I multiply that 144 by pi, I get 452.4, and this is inches cubed. All right, this next one says a sporting goods store sells exercise balls in 2 sizes. Standard, which is 22 inches in diameter, and jumbo, which is 34 inches in diameter. How many times as great is the volume of the jumbo ball as the volume of the standard ball, okay? So first I'm going to divide this by 2 because that means my radius here is equal to 11. And I'm going to divide this by 2, and that's going to be 17, okay? So I'm going to actually do my jumbo first, and you're going to see why in a minute. Now remember, this is 4/3 pi, and I'm doing my 17 cubed, right? All right, and then that's going to be equal to my standard, which is also 4/3 pi, and this is going to be 11 cubed. Now here's my question, because ultimately we're going to divide these by each other, okay? So when I divide out this and that, they're going to cancel each other out, right? And the pi's and the pi's. So really all I have to compare is the 17 to the third and divide it by the 11 to the third, right? So when I do that, I do 17 to the third divided by 11 to the third, and when I did that, I got 3.7. So it's 3.7 times larger the jumbo ball is, okay? So similarly on this one, it says giant squid needs eyes, large eyes to see the prey in the low light. The eyeball of a squid is approximately a sphere with a diameter, again, of 25 centimeters. So again, we're going to divide this by 2. So our squid radius is going to be what? 12.5. And then it talks about the human eyeball is approximately a sphere with a diameter of 2.5 centimeters. So the human has an eye. Again, we're going to divide that by 2. So that's going to give me 1.25. And remember, what are we going to do to both of these? We're going to cube them, right? Now remember, we don't have to do the other part because those are going to cancel out, right? So can you guys see that 12.5 divided by 1.25 is equal to 10? Me too. So you could actually compute that, but I know that 1.25 goes into 12.5 10 times. So this is going to be 10 to the third, which is 1,000. So if you can reduce the, remember, because these are both cubed, we can do that, okay? All right, so you try 4. Go ahead and do it. Come back to me when you're done. All right, so this is by 2, and this is by 2. So how much many times great is the volume of the soccer ball than the tennis ball? So we're going to do, again, the 15 cubed divided by the 3 cubed. So 3 goes into 15 how many times? That's 5. So that's 5 to the third. So that's going to be 125 times bigger, right? All right, so the next one just says the radius of the sphere is multiplied by 3/4. Describe the effect on the volume, okay? So we're going to take that 3/4, and because it's volume, we're going to cube it. So 3 times 3 times 3 is 27. 4 times 4 is 16, times another 4 is 64. So this, we try 5, says the radius of the sphere is multiplied by 3, so that's our change, and then it's effect on volume, right? So we're going to do 3 to the third again. So it's going to be 27 times bigger. The first one was smaller, right, because it's a fraction. Then it says the radius of the sphere is multiplied by 1/4. What is the effect? So once again, we're going to do 1/4 to the third power. 1 times 1 times 1 is 1. 4 times 4 is 16, times another 4 is 64. So it's going to be 1/64 the size of the original. All right, so the set of all points that 2 or more figures have in common is their intersection. When a plane and a 3-dimensional figure intersect, the 2-dimensional intersection is called a cross section. Okay? A 3-dimensional figure can have a lot of different cross sections depending on how the plane intersects it. So for this first one, if we intersect this where that red line is, you guys see a circle? I do too. And when you cut a hemisphere in half, don't you get a semicircle? You do. Okay, then we're going to talk about these rotations here, okay? So when we rotate this hemisphere around that, I should say that semicircle around that straight line, we rotate it 360 degrees, don't we get a hemisphere? We do. Okay. Now with this retry, we're going to rotate it around that straight line right there. So we're going to now rotate that hemisphere, which is oriented vertically, right? So this time, aren't we going to get a sphere? Okay. And then we're going to rotate this one through its center all the way around. And what are you going to get again? Another sphere, right? That's it.